The spaceship is ready to go. This time, we're not just walking around, we're looking for a new home for mankind. Perhaps we will stop at Mars and adapt the red planet to our needs, but you may have to fly a little longer. The planet Proxima b is 4 light-years closest to us and in many ways resembles Earth. True, it's a too-clustered star and drenched in deadly radiation. Maybe LTT 1445AS is the size of Earth, just discovered by astronomers 137 light-years away. From its surface, you can admire the incredible sunrises and sunsets of the 3 suns of this distant system. The exoplanet is in the habitable zone of one of its stars, but is literally orbiting around it in an embrace and is probably too hot. Well, onward we fly, and of course, we finally find a new home. How welcome and triumphant should our first step into this world be? Only we can't do that. Prolonged exposure renders us blind and weak, handicapped, unable to move on our own. The role of the evil demon that cripples us is ordinary gravity, or rather the lack of it. How can space travelers avoid the dangerous effects of weightlessness and make long flights without harming their health? To turn a spaceship into a giant merry-go-round, or to transfer gravity through the stars? Let's look at what works best for us. We all know why we stand firmly on the ground and do not fly off into space like balloons. In short, our planet is a massive object, because people, animals, buildings, and the computer you are watching this video on are attracted by gravity. Its main meaning to us is the acceleration of gravity, also known as g, which is 9.8 meters per second squared. At this velocity, any unsupported body is directed toward the center of mass. Due to this effect, the concepts of top and bottom arise and all matter falls to the ground. We are used to it and take it for granted. In fact, without gravity, our lives would be very different. Astronauts know this better than anyone, who spend a lot of time on the International Space Station. They relearn how to do many ordinary things: eating dinner, sleeping, hygiene. On Earth, without gravity, the situation would be even worse. Let's imagine that one day that force disappeared. Karen Masters, an astrophysicist at the University of Portsmouth, talked about the implications. According to him, the Earth is spinning as fast as a weight on a fishing line that you swing over your head. Without gravity, that line breaks. Things attached to nothing fly into space in a straight line. Anyone out in the open is immediately taken to a dark, cold room. People inside the buildings are better off because the houses are supported by foundations buried in the ground. Soon, however, luck turns away from them too. Gradually, the Earth's atmosphere, its oceans, rivers, and lakes are ejected into space. Our planet falls apart and is blown through space. A similar fate befalls the Sun. If gravity didn't hold it together, the core of a star would simply explode under the pressure of mass. The same thing happens to all sources of light in the universe. Eventually, there are no stars, no planets, not even remnants of matter, nothing. Space simply turns into a thick soup of drifting atoms and molecules. Fortunately, such a terrifying apocalypse scenario can safely be left to science fiction writers. Scientists confirm that nothing like this is actually happening. The gravity of the universe is perfectly designed and doesn't go anywhere, at least on Earth. Staying indoors for long periods of time is another matter. Where there are no massive objects, gravity doesn't work. Being weightless on long-haul flights is not very comfortable. However, this is the least of the problems that await us in the absence of gravity. The bodies of space travelers are irreparably damaged. So, recently, the results of a study of 11 astronauts who spent 50 days on the International Space Station were published. Because of the lack of gravity, 6 of them were observed to have blood clots. Most often, blood clots form in the jugular vein, most commonly in the internal jugular vein. This is the main vessel carrying blood from the cranial cavity. Scientists still do not know exactly what the consequences of this process can be, but either way, it doesn't bode well. It's like standing on your head for a long time. Over time, the state of health deteriorates sharply. Such processes seriously damage the brain. Researchers at the Medical University of South Carolina studied the head scans of 82 astronauts in detail, who spent over 6 months on the International Space Station. They found that prolonged weightlessness literally pulled their brains toward the surface of the skull and caused feather compression and twisting of the cerebral cortex. Such changes lead to increased intracranial pressure and loss of vision. But weightlessness hits the musculoskeletal system of space travelers the hardest. Loss of muscle mass in certain parts of the body in the long-term absence of gravity reaches 1–2% per month. It's the legs and back that are weakened the most. The bones would first literally crack at the seams and then fall apart. Calcium and other derived substances enter the bloodstream in large quantities. Excess of these substances can cause kidney stones, stomach ulcers, and serious heart disease. And this is not all the negative consequences of weightlessness. Researchers at the University of California found that this causes the integrity of the cellular barrier lining the intestines to break down. Such changes significantly increase the risk of astronauts contracting various infections, diabetes, liver disease. American Scott Kelly, who spent 340 days orbiting the space station, detailed the changes in his body after the flight. From the first minutes after landing, life for him became a living hell. The astronaut's entire body was in unbearable pain. Every joint, every muscle spasmed in protest against gravity. Scott was nauseous, shaking, and had a rash all over his body. His legs swelled terribly, and his bones were so thin you couldn't feel them. But his wrists and ankles were easily twisted into a knot, like ordinary rope. Kelly had poor spatial perception and was unable to perform simple tasks. After examination, it turned out that the astronaut had almost completely lost bone tissue. His muscles atrophied and blood redistributed throughout his body, causing the walls of his heart to contract and shrink. Researchers confirm that much deeper studies are needed to pinpoint all the reasons for the serious changes in the astronauts' bodies. Indeed, they hope that all the human organs will return to their normal earthly state on their own after a long stay in space. It is clear that space travelers cannot survive long flights without gravity. The way out of the situation is also clear. If there is no natural gravity in space away from massive objects, artificial gravity must be created inside the starship. The human body does not care what weighs it down. The main thing is to maintain physical activity and health. Then the crew will be able to work effectively with equipment, control the ship, conduct scientific experiments, and just live and rest to the fullest. It is not difficult for our viewers to understand what artificial gravity is. This is an artificial force that mimics gravity. Although our planet is a very massive object, it cannot be fully replicated for space flight. But what if we simplify the task? Create gravity by trying to trick your body a little bit. The minimum gravity that allows the human body to function normally in space is not yet known. Modern biology only understands the effects of Earth's gravity and weightlessness in low Earth orbit. On the Moon, where gravity is only 16% of Earth's, NASA astronauts have spent far too little time on it. Unfortunately, it is impossible to assess the effects of low gravity on the human body based on these experiments. While scientists focus on gravity, the solution seems to be self-evident. we have to make the spacecraft very massive. Experts believe this method is realistic because the effect of gravity has the necessary effect. Let's imagine we've taken a space trip in a ship like this. How do we feel in such a crazy machine? Probably protects you from unpleasant moments when the room is full. Thick walls provide better protection from cosmic rays than thin walls and protect against asteroid impact. And artificial gravity, due to the mass of the spaceship, perceives our body as an earthly one. True, the gravitational field must be distributed evenly in our spaceship. How do we do it? Scientists say it is possible to build a spaceship as a platform. This speeds up the crossing, but it is almost impossible to build such a massive starship because of complex technical solutions. So why not consider the simpler option of attaching a payload containing the mass of the Earth to the ship? This does not mean that its diameter should be almost 13,000 kilometers, as our planet has. A liter of Earth weighs only 336 grams on average, and we take something heavier, metals. Osmium is a leader among them. Its liter equivalent weighs as much as 22.6 kilograms, while, by comparison, a gold bar of the same size weighs 19.3 kilograms. In other words, you can create artificial gravity by attaching an osmium payload to a ship with a diameter nearly 200 times smaller than the diameter of the Earth. There's a lot more. You're gonna need an insane amount of metal. So much cannot be found in the bowels of the Earth. But let's assume that we have collected the necessary amount of osmium using, for example, stocks of other celestial bodies. But where to get such an incredible amount of fuel to pull all those hundreds of thousands of pounds? During flight, acceleration and braking, you need to make various movements. At this stage of development, it's unrealistic to collect that much fuel. At the same time, the idea of creating artificial gravity through the mass of the spacecraft is simple and clear, so scientists haven't completely rejected it until now. Creating artificial gravity using linear acceleration of a ship also seems to have little difficulty. Albert Einstein wrote in his special theory of relativity that gravity and acceleration are actually inseparable. Think of riding an elevator. At first, its speed increases and it seems to press you a little to the floor. Similarly, a constantly accelerating spaceship creates gravitational attraction. It affects acceleration in the opposite direction. Gravity may be weaker than on Earth, but it is surely enough to reduce the strain on the human body and make life on board comfortable. You can imagine how you feel on a long road trip. The comparison with an elevator is not quite appropriate. After all, acceleration in the cabin takes literally seconds. You can ride a roller coaster or a sports car, and then you can fully feel the gravity during acceleration. To create the necessary conditions on a starship, especially powerful and durable engines are needed. Electromagnetism that controls ionic currents is being developed. Engineers call them the most suitable for simulating gravity during acceleration, but in their current state, such engines can only provide a small artificial gravity. Such G does not exclude serious health problems in astronauts due to weightlessness. The main engine is getting more powerful and is almost ready. The project involves a nuclear reactor heating gases to very high temperatures. The gyroxio, they are ejected from the nozzle of the rocket, creating thrust. However, such an engine is very dangerous. There may start a spontaneous nuclear reaction corresponding to the explosion of an atomic bomb. This is why it has now been decided to postpone the project. But if someone in the near future invents a safe, efficient and long-lasting engine, that won't solve all the problems either. You will have to get a huge amount of fuel from somewhere to make the ship fly faster and faster. Another problem is the nature of the constant acceleration. According to our current understanding of the laws of physics, it is impossible to increase speed continuously. The theory of relativity does not allow it. Besides, in such a situation, the ship constantly has to fly somewhere, so there's no talk of hovering near planets, forced to behave like snot that stops and dies. And let's not forget the side effects. Our Earth is rotating along the equator at about 1700 kilometers per hour. We don't feel it because the speed of the planet is constant. Constant acceleration is likely to be difficult to maintain for long periods of time. It's not healthy for astronauts, and that's exactly what we want to avoid by creating gravity. It turns out that the idea of artificial gravity using the linear acceleration of a spacecraft is hardly suitable for us right now. But what if we take this idea in different directions, and in the fullest sense of the word? By rotating the base with the centrifugal force, we can create something similar to gravity. More specifically, its inertial motion away from the axis. NASA conducted various experiments in the 60s that showed that theoretically, creating gravity using centrifugal force is possible. Many use a centrifuge, a device that spins under centrifugal force. It is widely used to separate very dense, gaseous, liquid or granular bodies, and in other cases where higher gravity is required. In our situation, a rotating cylinder, tube or sphere is well suited for creating artificial gravity on a ship on Earth. Each of us has experienced a similar effect when driving a car and leaning sideways. In this case, it feels like the upper body is moving in the opposite direction to the rotation. When the car is traveling, the sensation is continuous until you get out on a straight road. However, the effect of the force weakens as the distance from the center of rotation increases. The artificial gravity is greater in the foot area than in the head. This can make it difficult for us to move and change our attitude. In order for us not to have such problems, the radius of the structure must be huge, at least 220 meters. It's about the height of a 95-story building. At the same time, astronauts experience almost the same gravity as the Earth. Building such a colossal ship is theoretically possible, but it requires such enormous resources, effort, and time that the project is unlikely to materialize in practice. Researchers at the University of Colorado at Boulder have a smaller proposal. They have designed rotating systems that would fit in spacecraft compartments. Of course, the structures do not provide artificial gravity to the entire spacecraft or station. However, they do allow astronauts to spend a fair amount of time in conditions close to Earth's gravity. The system uses centrifugal acceleration, which mimics a 1G gravitational field as on Earth. To use it, a person must lie on a centrifuge that has a small radius to spin quickly, but constantly spinning around like on a merry-go-round is not the best solution for staying healthy. Anyone who has been spinning for too long knows that it can be difficult to get the hang of it. The rotation can seriously damage the heart, nervous system, and other human organs. Experts say the long, spinning rod-like vehicle causes fewer side effects. The idea is to place a nuclear reactor at one end of such a ship with a diameter of about 100 meters and a combat compartment at the other end. However, the project has encountered technical problems, so it's still a long way off. There is still a long way to go before it is realized. However, experts tend to believe that a rotating spacecraft is the best idea for creating artificial gravity. In space, it is not perturbed by any force other than friction. Powering a starship is therefore the cheapest of all options in terms of energy consumption. Scientists are moving in this direction and offer new developments. Would you like to have an amazing experience? We will then take an incredible tour of these futuristic space structures. Perhaps we will see a huge Ferris wheel spinning on its axis in the sky and find colonists in special life capsules attached to the wheel. NASA is preparing a similar prototype capable of autonomously generating gravity in space, or maybe before we can venture into space, we'll encounter something even bigger. There are giant cylinders soaring through the sky named after O'Neill, who wrote the methodology. In the design, the structure consists of two massive cylinders rotating in opposite directions. Joseph Bezos, owner of the space company Blue Origin, hopes to launch similar floating space colonies into orbit in the future. They could become a permanent home for millions of people. It's unknown whether Bezos will succeed in his grand plan to host an orbital colony, but its design doesn't quite match that of a spacecraft. According to scientists' calculations, the minimum length of O'Neill's cylinder should be 32.2 kilometers and its diameter should be 6.4 kilometers. It's too big for a starship. Moreover, sometimes you can use a simple and cheap version of a cylinder. Simply launch the structure into orbit and inflate it like a balloon. However, the development of additional safety measures for inflatable space structures is still needed because the risk of their collapse is still too high. Meanwhile, we're off to a 5-star space hotel with the most advanced service. We are talking about Voyager, an orbital station with artificial gravity announced for 2021. Construction of the station will begin in 2025, and in 5 years it should receive the first tourists. The commercial Voyager project has a ring with a diameter of 200 meters. Artificial gravity inside it is achieved by rotating it at a certain angular velocity. Let's say the gravity inside the hotel is the same as on the Moon, but as we said on our satellite, it's only about 16% of Earth's gravity. This is the Tuebari era. It is not clear whether this capacity is sufficient to provide comfort for tourists. An excellent place to study the effects of low gravity could be a laboratory located on the Moon. Unfortunately, such a research center does not exist yet. However, the creators of the station hope to comfortably accommodate scientists and tourists there. There will be 24 accommodation modules built for the tourists. They can accommodate 400 people at a time. Inside each module, travelers have their own spacewalk gate. Travelers have the opportunity to get useful information in thematic lounges, eat and drink in restaurants and bars, visit the spa center, and watch movies in the cinema. All in all, pretty secular entertainment, but the reality is still a long way off. Work begins with the construction of the station itself, or rather its prototype, which has a diameter of 61 meters. The company has already patented the robots that are assembled right in orbit. The prototype will be used as a test bed for theories and experiments leading to the creation of Voyager itself. Other methods of creating artificial gravity are also being developed. One of them is the use of the effect of diamagnetism. The method is based on the fact that simple magnets can press astronauts to the floor like ordinary gravity. Can such artificial gravity create a polar glow that follows the contours of the ship? This question was asked by a viewer of our channel, but unfortunately, science does not give a precise answer. But let's think together. It is known that artificial aurora borealis can be made, and it is not difficult at all. It is enough to place an electromagnetic coil inside a metal ball and the ball in a vacuum chamber. The gas must then be distributed between the metal plates that contain the balloon. Gases create a miniature version of Earth's atmosphere. When bombarded by electrons that mimic the solar wind, the magnetic field pushes the electrons towards the poles where they excite the gas molecules. And it will emit fantastically beautiful light, just like the real northern lights, only in miniature. Therefore, we can assume that artificial gravity, with the help of magnets, can move the body along the aurora borealis. This is only possible in an environment at least somewhat saturated with gases. True, it is unlikely that we space travelers will soon see all this with our own eyes. Although scientists have already modeled gravity through demagnetization, it cannot yet be replicated on a spacecraft. The problem is that the magnets weaken in proportion to the square of the distance. If you put them under a meter-long blanket, for example, they will pull mostly on the legs, while the rest of the body remains weightless. Giant magnets the size of mountains create a very strong magnetic field affecting the body of the entire crew. Of course, it is difficult to achieve such a large-scale index on a spaceship. In addition, scientists believe that the model is far from safe for humans. On the other hand, diamagnetism allows for low gravity without jeopardizing human health and life. This is about the same as on the Moon or even on Mars, where G is about 40% of Earth's, and the first practical experience of such a design is already in place. In January 2022, China built a research center to simulate the low gravity of the Moon using magnets. This small structure has a diameter of only 60 centimeters. However, if you are working with large magnets, things are much more complicated. To preserve their superconductivity would require very expensive cryogenic technology, not to mention the enormous power of the device, which is very difficult to achieve, so this project is still far from full realization. Another way to create artificial gravity on a spacecraft, a near-perfect method that virtually eliminates the acceleration and side effects of infinite rotation, providing astronauts with a constant downward thrust. In order for this to happen, you first need to find a negative gravitational mass. It is present in the calculations of scientists, but no one has actually found it yet. Alpha collaboration physicists are currently actively searching for negative gravitational mass in the Large Hadron Collider. Scientists have already obtained a stable form of antihydrogen, neutral antimatter. Now they are trying to separate it from all the other particles. Scientists hope to find out in which direction antimatter moves in the gravitational field. When it starts to fall normally, its gravitational mass is greater than zero. In this case, such particles cannot be used to create a gravitational conductor, but when the antihydrogen falls out, it changes everything. Suddenly, artificial spacecraft gravity becomes real. In addition, its creation doesn't require complex structures or spectacular technical solutions. To understand the properties of antihydrogen, CERN scientists are changing the strength of magnets by observing the effect of gravity on it at different speeds. But this is only the beginning of the journey. Many more precise measurements of the effects of gravity on antimatter have yet to be made. If the desired properties of antimatter are confirmed, it is enough to make the ceilings of the spaceship rooms. The astronauts are then continuously pulled downward in the opposite direction. But until scientists find a particle or set of particles with negative gravitational mass, this amazing method will have to wait. However, there are many simply wonderful concepts for artificial gravity for space travel. However, not all theories are still detailed and do not require technologies of the very distant future. And in general, let's familiarize ourselves with the most interesting ideas among them. We've talked to you many times before about gravitational lensing. The phenomenon is associated with massive space objects, planets, stars, galaxies, galaxy clusters, or dark matter. Using their gravitational field, they can change the direction of electromagnetic radiation. Similarly, a conventional lens directs the vector of the light beam. This allows astronomers to observe the most distant objects in the universe. For example, recently, using the Hubble Space Telescope, they discovered the galaxy J1000 plus UA221 almost at the edge of the universe. In our case, a gravitational lens can come in handy because it can create artificial gravity. Only this requires placing a massive object, such as a planet or star, between the spacecraft and the destination. Now, of course, the version seems completely unrealistic. But in the future, who knows, maybe we'll learn how to move furniture, massive celestial objects, wherever necessary. Gravity generators are another idea of scientists that is still close to science fiction. These are incredible properties that utilize cosmic gravitational fields or dark energy for artificial gravity. Of course, no one has ever developed such hypotheses in practice. We haven't even fully investigated the phenomena necessary for it to happen. In general, it can be seen that the situation with artificial gravity is developing very slowly. However, without it, we cannot talk about human space exploration. Scientists believe that a breakthrough is possible if we deeply understand the nature of gravity itself. It is still impossible to say exactly what causes it. And of course, it's hard to tackle something you don't fully understand. There are such examples in our history. Besides, the whole attempt to use the transatlantic telegraph cable failed because the electron had not yet been discovered, and the connection between electrons and magnetic fields was thought to be unreal. But we found the connection and will certainly understand the nature of gravity in time. And then creates spaceships with artificial gravity. What would they be like? Like Starship Discovery's spinning centrifuge in 2001's A Space Odyssey? Or like the Endurance from an interstellar thriller spinning around a central axis? Or we'll come up with something completely new that we can't even imagine right now? It doesn't matter.